We're going to go through problems 4, 5, and 6 and the answers. So to find that proportional relationship, before we just really looked at it visually after graphing a small set of points and saying, okay, does it start in the origin? Is it linear? Is there a multiplicative relationship? And that was our test to see if it was proportional or not. Now we know that we can either take all the y over x's or x's over y's between any of the coordinates on the line, and we can decide whether or not it's proportional by just making sure they have the same constant. So I looked at scenario 2, which is y equals x plus 6, and I looked at 0.1 and 7, 2 and 8, 3 and 9, because x equals 1, then plus 6 equals 7, x equals 2, then plus 6 equals 8, and x equals 3, then plus 6 equals 9. And this is really just some of that work that we did earlier on our tables that we created. Okay. So if I take y over x, and it's 7 over 1 or 7, 8 over 2 or 4, 9 over 3 or 3. So these are not proportional because every time I divide every time I express y over x, I get a different constant. So now I'm going to look at scenario number 3, where we got 0 and 0, 1 and 1.6, 2 and 3.2, 3 and 4.8. This was a multiplicative relationship that had every x or every y equaling x times 1.6. So 1 times 1.6, if I express it as y over x, I have 1.6 over 1, and my constant is 1.6. If I take 2 and 3.2, which is another plot point on the line, and I take 3.2 and divide it by 2, or y over x, I get 1.6. And then 3 corresponds with 4.8. If I take 4.8, divide it by 3, or put it in the y over x expression, I get the same constant as 1.6. So that means scenario 3 is proportional. Now, Isaac says that y equals pi times r squared represents a proportional relationship because it's multiplicative. All right. So we have to prove why he's wrong, and we know he's wrong because we have a thumbs down here. Okay. So it says use a table of values corresponding from the ratios in the form of y over x to explain why Isaac is incorrect. So all I did here was write out my equation, y equals pi times x squared, which x would be the radius, and pi is 3.14. Then I took and I plugged in an x. So if I plug in x, 1, square it, it's still 1, multiply it times 3.4, and my y over x is 3.14 over 1, which is just 3.14. Now I'm going to go ahead and put in 2. 2 squared is 4, times 3.14 is 12.56. Now I'm going to go ahead and take 12.56 and divide it by 2, as expressing it as y over x, and I have 6.28. So right away I have two different constants when I express it as y over x. So I know it's nonlinear. Okay. Problem number 6 says, explain to Isaac how the different graphs are different. Use terms like linear relationship, nonlinear, proportional, and equivalent ratios. So I'm just going to go ahead and look at these graphs. This is nonlinear because it doesn't create a straight line, but it is multiplicative, right? The next one is a linear relationship because it creates a straight line, but it's an additive relationship, right? So it's not proportional. And finally, y equals 1.6 times x. This definitely is a linear relationship. It starts at the origin and creates equivalent ratios throughout. So it is a proportional linear relationship. And that's what I would tell Alex. Great job, you guys.